Hello, I'm Pierre, product developer at Inetec. We are proud to introduce you to Dolphin 128 by 128 PR, Inetec's best-in-class phased array ultrasonic instrument. All types of probe can be connected to Dolphin, from phased array to conventional, including Tuft. Phased array probes with up to 128 elements can be connected to Dolphin via the hypertronic connector. The second hypertronic connector can be used to connect TRL phased array probes with 128 receivers that are independent from the pulsars. 16 fully independent channels can be used to connect mono and dual element ultrasonic probes. Let me now demonstrate Dolphin's performance with a 2x16 TRL phased array probe with a wedge angle of 19 degrees and a roof angle of 1.5 degrees. I will calibrate the probe on a IIW Type 2 reference block made of stainless steel, and I'll demonstrate the signal quality on a welded block of 316L with 3 artificial notches. Let me connect the Dolphin instrument. I will plug the power outlet, turn on the instrument, connect the Ethernet cable to the computer, and connect the probe via the hypertronic connector on top of the Dolphin instrument. I'll place the probe on the calibration block and I'll start the Signy1 software. The Signy1 software is compatible with all instruments from the Dolphin family. Signy1 is used for job preparation, acquisition and analysis of ultrasonic data. Job preparation can be done without an instrument being connected. Let me now set up a new configuration for this probe. I first go to Instrument, Probe, and I will set up this phased array probe with the information for our probe. Here I can input all information about the geometry of the phased array probe, or I can load a file that has been shipped together with the probe. The geometry of the probe has been loaded, and I will scan from a refracted angle from 0 to 80 degrees every 1 degree. The focusing is done automatically based on the geometry of this probe. The focal laws are now updated on the probe, and I will be able to calibrate it for this inspection. I will update the probe range and I will start acquisition. First I need to connect to the instrument, and then click start. The probe is on the reference block with 3 side drill holes at 30 mm depth. I will be calibrating the wedge delay on the middle side drill hole. I select the area of the peak, I go to calibration, I select wedge delay, the probe is at 30 mm depth. The peak is now at 30 mm depth. I will now move the probe on the welded block made out of stainless steel, and I will calibrate the gain so that the noise is at 5% amplitude. I go to calibration gain, 5%, and I calibrate. Signals are now stronger, and the backwall echo can be seen here at 60 mm depth, and the 2 notches can be seen here. When I move the probe, I'm able to measure the position of the top and bottom tips for the 2 notches. Additionally, when I move closer, I can see the pilot hole for the 3rd notch at around 10 mm depth. The probe has been calibrated and we confirmed that the signals are optimal for our inspection. We are now ready to perform an inspection with Dolphin 128 by 128. Hopefully this has been insightful for you. For additional information, reach out to us on the contacts below.